Hello and welcome to Types of Chemical Reactions by Dina Ciccone. In this lesson, we're going to talk about the 5 main types of chemical reactions. I'm going to show you the 5 reactions on 5 different slides. I would like you to pause each slide, write down the general equation, the examples that I gave you, and at each slide there is a hint at the bottom that will help you later on in the course. Okay, the 5 main types are a synthesis reaction, a decomposition reaction, a single replacement or displacement, you'll see it written both ways, reaction, a double replacement or displacement reaction, as well as a combustion reaction. The first reaction we will discuss is the synthesis reaction. A synthesis reaction is where you take 2 or more things and create one brand new product. Here, my reactants are A plus B yields AB. I've done it in color as well. Yellow plus red yields orange. The 2 examples that I have are, here we have 2 elements to form a new compound. So we've got calcium plus oxygen yields calcium oxide. And here I've got 2 compounds to form an even larger compound. I've got calcium oxide plus water forms calcium hydroxide. The hint that I would like you to write down is that synthesis reactions always have just one product. And the word synthesis means to make something new, to synthesize. Here we have a decomposition reaction. Decomposition is to decompose or to break down. You might remember that word from biology class. We have AB yields A plus B. It's just the actual reverse of the synthesis reaction. Here I have the orange, and I break it down into the yellow and the red. Here are 2 examples of synthesis reactions. The first one, I'm going from a compound into its 2 elements. Water decomposes into hydrogen and oxygen. Here, I have a compound breaking down or decomposing into 2 different compounds. I've got calcium carbonate yields calcium oxide plus carbon dioxide. The hint here is that all decomposition reactions have only one reactant. 1. Again, please write these down. Now let's get into the 2 that we'll be dealing with most in our class. The first is called a single displacement reaction. What this is one metal, A, plus an ionic compound, which is BC, keeping in mind that an ionic compound is nothing more than a metal plus a nonmetal. Well, over here, A plus BC yields AC plus B. All we've done is the A and the B have switched places. So B was the metal with this nonmetal. On this side, A is now with that nonmetal. Here I've done a graphical representation, and I've given you 2 examples. The first one is going to be aluminum plus copper 2 chloride yields aluminum chloride plus copper. Then I have silver nitrate plus aluminum yields aluminum nitrate plus silver. Notice that all of my equations are balanced. That's what the black coefficients in front of each compound mean. The way to easily identify a single displacement reaction is that on both sides of your equation, you have one metal and one ionic compound. We will use a chart called an activity series. We will do that in class, which will show us whether a metal can take the place of another metal or not. It's really just a popularity contest. Okay, our next reaction is a double displacement reaction. It's similar to the single displacement, but instead of having a metal and an ionic compound, I have two ionic compounds. AB plus CD yields CB plus AD. All that's happened here are the metals have switched places again. So A and C on this side are now flip-flopped on the other side. That's simply a double displacement reaction. Here are my two examples. I've got silver nitrate plus sodium chloride yields sodium nitrate and silver chloride. Then I've got potassium hydroxide plus H2SO4. Do you remember how to name H2SO4? Well, I'm going to say this is sulfuric acid. So potassium hydroxide and sulfuric acid yield potassium sulfate and water. The hint here is that on both sides of the equation you have two ionic compounds. You must have the two ionic compounds in order for the metals to switch places. Okay, now we're going to get to my last slide, which I think is by far the easiest to remember. This is called a combustion reaction, and I'm quite proud of the job I did making the molecules. A combustion reaction is an alkane, if you can remember that from our last unit, which is nothing more than a hydrocarbon in the presence of oxygen, will always yield carbon dioxide and water. This equation never changes except for which alkane we use. Here are some examples. Oh, look at this. I've got one carbon. What do I call that? We used the mnemonic, monkeys eat, what did they eat? Peeled bananas. Monkeys eat peeled bananas. So if monkeys is my first one, this must be methane. Methane plus oxygen yields carbon dioxide and water. Let's come here. Oh, I've got 4 carbons here. So again, let's see, monkeys eat peeled bananas. So B is 4, so this must be butane. I have butane in the presence of oxygen yields carbon dioxide and water. Your hint is that a hydrocarbon with oxygen will always produce carbon dioxide and water. If it is not a hydrocarbon, then it is not a combustion reaction for our class purposes. This is the end of the presentation. Again, if you did not already do so, please go back through each slide, stop, and take good notes because I will be testing you on all of this. Until next time.